In this video, we're going to look at two slightly harder projectile motion questions. Question 1 is here. Pause the video now and try this question. Part A requires us to calculate the maximum height of something that's being thrown. So as usual, a diagram is very, very helpful. So something is being thrown at 26 meters per second at an angle of 28 degrees to the horizontal. And then obviously over time, it's going to follow a parabolic path and end up back down here. So we're obviously ignoring air resistance. If we were asked to take into account air resistance, obviously the path would be shortened and it would look a bit more like this, where it's a bit steeper here, but we're ignoring it. So how are we going to solve this? How are we going to find its maximum height? Its maximum height is going to be up here. And importantly, its maximum height is going to correspond to a point where the vertical velocity is 0. So we're going to start this problem by only looking at the vertical motion. And again, like I said in the previous video, the X and Y motion, the horizontal and vertical motion, are independent of each other. So we can look at purely the Y and it won't be affected by the X motion. So what is its maximum height? We're trying to work out S. What is its initial velocity? Well, we want the initial velocity in the vertical direction. So what's this initial velocity here? Well, it's asking us for this component here. So that's going to be 26 sine 28 degrees. The acceleration is minus 9.8 meters per second squared. So importantly, it is minus because it's going upwards and it's being slowed down. So the minus is important. And then time, we don't know, and at the moment we don't actually care about this. So what equation has each of these variables in? S is, so we should probably use V squared is U squared plus 2AS. So S is V squared minus U squared over 2A. So let's plug in our numbers. V squared is 0 minus U squared over 2 times 9.8. And I'm going to put the minus here. And now you can see these minus signs cancel out. So we're obviously going to get a positive height. If you used a positive value for acceleration here, you'd end up with a negative answer. You'd get the same answer, but it would be negative. So strictly speaking, it wouldn't be correct. So now we can plug in our numbers. 26 sine 28. Make sure you put the brackets around the 28, otherwise you'll get the wrong answer. 2 times 9.8, which is 7.6 meters. Calculate the time it takes to hit the ground. Assume it was thrown from an initial height of 0 meters. So the time it takes to hit the ground is going to be twice the time it takes to get to the top. So it will take a time to get up here, and then it will take the same amount of time to get down to the bottom. So now we're being asked to work out the time here. So we've got V, U, A, and S. So the easiest way to do it is V minus U over A is T. So that comes from V equals U plus AT. So the time is V minus U over acceleration. And again, you can see that the minus signs cancel out. So I'm not getting a negative answer that wouldn't, strictly speaking, make sense. So 26 sine 28 over 9.8 gives us a time of 1.25 seconds, but this is just the time to max height. So the total time is 2 times 1.25 seconds, which is 2.5 seconds. Part C, calculate the horizontal distance it travels. Well, this is really easy now. We've got the time is 2.5 seconds. We've got the horizontal speed. Maybe I should put UY there. I'm going to use UX to work out the horizontal speed. Well, this is easy. We want this component here, the horizontal component. So that's going to be 26 cos 28 degrees. And this horizontal speed is not changing. So it's simply distance is speed times time, 26 cos 28 degrees times by 2.5 seconds, which is 57 meters. Question 2 is here. Pause the video now and try this question. So we've got a much more complicated situation here. So a diagram is, of course, crucial. So we've got our bird, and excuse the poor diagram. This bird is traveling at 4.5 meters per second at an angle of 40 degrees to the horizontal. So 4.5 meters per second at an angle of 40 degrees to the horizontal. And it says here above the horizontal. So we know it's going up. It releases a stone it was carrying. Find the vertical and horizontal components of the stone. So the stone is going to start here. It's going to be released and it's going to follow a path that looks like this. So its initial velocity will be 4.5 meters per second at an angle of 40 degrees. And then it will end up on the ground some distance below where it started. So horizontal and vertical components of the stone. Well, firstly, this is quite easy. UX, we want this component here. So 4.5 meters per second times by cos 40 degrees, which is 3.4 meters per second. And the initial vertical component is going to be 4.5 sine 40, which is 2.9 meters per second. I'm just going to put in brackets up because that might be important later. Part B, the stone took 5.8 seconds to hit the ground, neglecting air resistance to work out how high the bird was. So this is now a tricky question that's going to involve quite a few steps because we have to take into account the fact that the stone is going to go up and then it's going to go down again. So what we really need to do is work out the time it takes to go to this point here. And then we can work out the time it takes to fall down. Or we can use a bit of a trick here. We can use a Suvad equation and we can use the fact that vectors apply. So there's nothing wrong with doing it in two stages, completely fine, but this is a bit quicker. So we're trying to work out S. We know what U is. It's 3.4 meters per second. Actually, no, we don't. This is a mistake. We want vertical. So it's really important that you're clear whether it's vertical or horizontal. So actually writing this out, writing little headings out is really helpful. So U vertical is 2.9 meters per second up. V, we don't know. We actually don't care. A is 9.8 meters per second. So now I need to be really careful with my choice. So my initial velocity is 2.9 meters per second up. So I'm going to say that's positive, which means my acceleration, because it's trying to pull the stone down, is going to be negative. And then the time is 5.8 seconds. So what equation has all of these in? S is ut plus half at squared. And you might now start to see the trick here. So S is 2.9 meters per second times by our time, which is 5.8. And then it's going to be minus half times 9.8 times by 5.8 squared. So I'll just put the minus sign for the 9.8 here. I've just moved it in front of the half. So now we've actually just got one equation and I've got this minus sign here. And you'll see when we work out the answer exactly what this means. So now we've got an answer of minus 148 meters. So what this is saying is the stone's displacement is 148 meters below the starting position. So what does this actually mean? It means that this distance here is minus 148 meters from where it started. So it means that the distance the bird is, or maybe I could say the height of the bird, is obviously just 148 meters. So we're using the fact that this placement is a vector, which can be positive or negative, and the fact that we've got our initial velocity up and our acceleration pointing down. And then finally, C, how far did the stone travel horizontally? This is really easy, the same as the previous part C. We're doing ux times by the t, so it's traveling at a constant velocity horizontally, it doesn't change. So now we need 3.4 meters per second times by 5.8, which is 19.7 meters.